All right, AP Physics 1. This is your measurement in physics recorded notes. We're primarily doing this as review information on metrics and some basic trig and our general unit of measurement that we will use in our physics class. So SI units, SI is really the system of international units, and that is the same thing as the metric system. And so we do basic length, mass, and time measurements. And when we do length, we will measure it in meters. And when we do mass, we will measure it in kilograms. And when we do time, it'll be measured in seconds. It's important that you understand that these are the basic units that we will use when we do all of our measurements, and everything always needs to be converted into these basic SI units. So if they give it to you in something else, you're going to have to change it to these units. So there are a lot of other units to consider, but most of the time we're going to be using these, and we can express these in different types of units by adding prefixes in front of them. This is either to make the number larger or smaller. The nice thing about the prefix is that you can write a couple of numbers down and have the unit signify something much larger. Also, all of these are listed on your formula chart that you're going to get. And so you don't have to memorize your metrics conversions. You just have to know how to use them. So 1 kilometer, the unit itself denotes that the number is actually larger than 1, considering its fundamental units. So the fundamental unit would be 1,000 meters, because the kilo is adding to the base meter. Okay, these are your common used prefixes, and again, all of these are on our physics formula chart that I'll be giving you. But if you forget a prefix, by all means use that formula chart and you'll be able to have it. Mega is going to be used when we talk about radio stations and sound waves. Kilo, lots of times, is used about instead of miles. And especially in our class, we do not use miles, we use kilometers. And then we actually break it down even into meters. But that's the similar units between the two. Centi is something small, and it's typically used in optics. We use that more actually in AP2 than we do in AP1. But this is the unit most people forget to convert in AP. And then milli is sometimes used to express really small distances. Micros is used when we talk about electronics and charges, so we'll talk about that. And nano is used when we're talking about distances between wave crests, when we talk about light in the electromagnetic spectrum. Again, light in the electromagnetic spectrum are primarily used in AP Physics 2, not AP Physics 1. So if I have a capacitor, which is an electrical piece of equipment, and it's labeled as 2.5 microfarads, if I wanted to label that in just farads, okay, farads is the base unit, so I could look back and say that the fundamental unit would be a micro is just going to be the base unit of what I was given, the 2.5, times 10 to the negative 6th farads. So all I had to do was add the times 10 to the negative 6, because that's the subscript for, or that's the conversion for micro to regular. And so if we go back a slide real quick, remember where I had micro, it said times 10 to the negative 6. So you can just add that to the base number. Okay, so here I have a radio station that's 106.7 times 10 to the 6th hertz. So in megahertz, it would just be 106.7, because that's the times 10 to the positive 6 is the mega conversion. So notice we just added the factor to the end to use the root factor, and here we just dropped the factor to take it back to a prefix and added the prefix. So it's just a way of, not really changing the number, just adding the factor accordingly. Another way to do it is to do dimensional analysis, which all of you should have learned in chemistry class. And so dimensional analysis is just a way to convert from one unit to another by using ratios. And so the main thing to remember is that the given unit must cancel out. So if we want to go from 65 miles per hour, then we could go to feet per second, and then we could go to meters per second. So the thing to think about is if we just want to start with the time, we have hours on bottom, and then we have hours on top. And then we have minutes on bottom and minutes on top. So those would cancel out, okay? And then we would just end up with miles over seconds if we did the math. So we take 65 divided by 60 divided by 60. And then we would use miles on top and miles on the bottom, and those would cancel out. And now we're in feet per second, but we want to be in meters per second, so we need to convert from, so we could end up with this right here. Once we have that, we could go ahead and do one more and say that for every 3.281 feet is 1 meter, so the feet would cancel out, and we would end up with meters per second. We can do this step right here. It could be added right up here, and it wouldn't be an issue, and we could still just multiply and divide everything. So we could add it right there and just do it all in one step even, and not do it as two broken pieces like this. But that's just a way to look at it, and we would end up with 29 meters per second. Okay, so now I want to go from 5 years to minutes. Okay, so I want to start out with what I'm given. So 5 years, and then I do the T-chart thing. So I don't need anything on the bottom, but from every 1 year, there's 365 days. So the year cancels out. And then for every 1 day, there's 24 hours. So the days cancels out. And then for every 1 hour, there's 60 minutes. So the hours cancels out. I then would multiply all of these out, and I would multiply 5 times 365 times 24 times 60, and I would end up with 2.63 times 10 to the 6th minutes. So if I click on my screen, oh, that is not the same answer. What did I do wrong? I don't know. Somehow, though, I made a mistake, okay? I wanted to do this so that I could say, you need to make sure you work your stuff out. If this happened in class or even on this recording, I would hope somebody would bring it to my attention that this was not the right answer. Okay, so if I hadn't done the right answer up here and I just popped up the 109,500 minutes, it's okay to say I'm wrong. Remember, I am human too. Okay, so I do have it written wrong on that slide on purpose so that hopefully someone would bring it to my attention. Okay, so for the next one, 25 kilometers per hour to meters per second. So I said it was 6.94 meters per second. Let's actually do the work and see if that works out. So I'm going to start off with the 25 kilometers per hour. Notice on example 1, I didn't have anything underneath because I was just going from one unit to another. Here I'm going from one unit on the top and one unit on the bottom. So I can only have one unit in a box at a time. So that's how I have to write it. So I'm going to do my kilometers first. So for every 1 kilometer, there's 1,000 meters base unit wise. So then my kilometers cancels out. Then I'm just going to keep going. And for every 1 hour on top, I have 60 minutes. And actually, I'm going to do something real quick here. I also know that for every 1 hour, there's 3,600 seconds. So I can actually skip a step if I do that, and I can make it like that. Now I've ended up with just my meters on top and my seconds on bottom. So now I can just do the math. So taking a calculator, I can do my 25 multiplied by 1,000 divided by 3,600, and I end up with 6.94 times 10 to the, or 6.94 meters per second. So that answer is correct. All right. All right, trig functions. We will be using Pythagorean theorem, and we will use trig. Everything we do in physics, because it's algebra-based, will be right angles. So all of these are also underneath the geometry section of your formula chart. But a squared plus b squared equals c squared, we will use that. Remember, to find an angle, you're going to use the inverse trig function of, so we could use the sine to the -1, or we could use the cosine to the -1, or we can use tangent to the -1 to find the angles. But sine, remember, is so, and then, so that's the sine is opposite and hypotenuse. Cosine is adjacent over hypotenuse, and tangent is TOA because it's opposite over adjacent. I have an example here. I could have the information here about this building, and I could, I know the angle on a side. If I want to know how high it is, I could use tangent, and so I could take tangent 39, multiply it by 46, and find the height to be 37.3. The thing about your calculators is you need to make sure they are in degree mode for my class. All right, they got to be in degree mode, not radians. Then, if I wanted to also find the hypotenuse, if I wanted to find how far away I'm looking up at the ceiling or up at the top of this building, then I could do my a squared plus b squared equals c squared, and that would give me my 59.2. I will tell you in this class we're primarily going to round everything to 2 numbers after the decimal. We're not going to worry about significant digits. Yay! Not required for physics class. All right, so the truck driver moves up a straight highway, mountain highway is shown, the elevations are marked, and so I want to know actually how to find the angle. So I have the opposite side and I have the hypotenuse, so that would be my sine for so. So I could then do sine angle equals the opposite over the hypotenuse. The key thing to remember here is that these units have to match also. So to find the angle, we would divide by sine, and when you divide by sine, it really is sine to the -1 power of this ratio, and so you end up with 10.2 degrees. Again, if there's more than one digit after the decimal, I want you to give me 2. Okay, hopefully that gives you a slight review of some measurements that we'll use in physics class. See you in class.